Thank you everyone for joining us today. It is December 12th, 2016, SIG-Apps. We have a fun agenda today. We have two demos. The first is OpenStack on Helm by SAP, and the second is Fission, which is a framework for serverless on Kubernetes. And after that, we have some stand-ups. If you have something to add, like an agenda item, a stand-up for yourself, or something to discuss, please do so on the doc now. And then we'll discuss a proposal, and after that, we'll do the 2017 planning. So, OpenStack, are you ready for the demo? Go ahead and feel free to take over.
Yeah, sure. I guess we are. So, hey folks, my name is Michael Schmidt. I'm here with my colleague Andrew Betty. We are both working for SAP. I'm based in Berlin. He's from London. And we are deploying OpenStack with Helm. And we want to give you a demo of that. And before we start with the demo, I want to give you a bit of context to why we are doing this, so that you don't think we're just some lunatics doing a really complicated Helm chart. So I hope this works, and I'm sharing my screen. So we are in the business of, at the moment, installing multiple data centers all over the world. We're looking at 18 data centers, and our customer offering is actually OpenStack. Why Kubernetes? We actually think that deploying OpenStack on Kubernetes is the best thing for us to do, because we need to manage all of those OpenStacks. So we are kind of using Kubernetes as an abstraction on our bare metal data center. So our stack looks like this. We have like hardware on the bottom, and what we get in our data centers is someone is rolling in like bare metal racks, and our remote hands put the cables in, and then we get the machines, and they're completely bare. And we don't have an undercloud or anything in our data centers. We need to do everything ourselves. So we're going with the GIFEE stack that Kolla showed. We have Kolla on the bottom, put Kubernetes on top, and then we're using Kubernetes to actually deploy our OpenStack. The containers we're deploying, they come out of the OpenStack ecosystem. There's a distribution called Kolla, and we're building those containers ourselves. And traditionally, the Kolla project is also providing orchestration and tools to deploy the OpenStack. We started doing that and using their tools to run OpenStack on Kubernetes. Then when we figured out that it's not enough, we built our own tooling. And when we figured out that this is quite complicated, we eventually rebased on Helm. So over the last few months, we've been rebasing all our work on Helm. And we're not just deploying OpenStack, but also many monitoring solutions or other tooling, which we need around it. So Helm is just a almost perfect solution for us, because we can leverage what the community is giving us, and we can deploy OpenStack. Fortunately, we need to build the OpenStack stuff ourselves, and it's rather complicated, but that's why we're here, and that's why we want to show it to you. So with that, I would like to hand over to Andrew, who's giving you the rundown of the demo. Hope you're here, Andrew.
Yeah, hi. Sorry, I'm just trying to share my screen. So hopefully you can see my screen. So as Michael said, this is I think the third iteration of our deployment process. So we initially started with a bash or a set of bash scripts and some Python tooling. It was too complicated. We realized we were just creating sort of native Kubernetes specs that we just wanted to upload. So we wrote a small Go extension to the Kubernetes client to do that with a little bit of template handling. And then we realized someone else had already done that with Helm. So we've moved over to Helm. So what we've got in our cluster, if I just show you, as Michael said, we've got a full OpenStack control plane and a bunch of other tools around monitoring. And they're largely organized, if I can just go back to wherever I was. They're largely organized into namespaces within Kubernetes. So the one we're interested in today is this Monsoon 3 namespace, which has got all of the OpenStack components that we've deployed. And at the moment, we're largely putting a single, or in general, a Helm release mapped to a namespace. So if we look at, if I just bring in my Helm, the Helm releases that we've got in here are, we've currently got one which is the OpenStack region, which corresponds to that Monsoon 3 namespace. We've got some stuff for monitoring, Prometheus, OpenStack CLI-meter, some of the DNS tooling we need to support the OpenStack DNS stuff, and we've got other things in here around things like Manaska, which is an OpenStack monitoring tool, which we're still deploying in our legacy format, and we're looking to migrate over to Helm, or we're in the process of doing that. And what we've done is we've created charts for, if I can find my browser. We've created charts for each OpenStack component that we're deploying, which is pretty much most of the core OpenStack environment. And what we've done is, I don't know if it was clear from Michael's presentation, but we've made a clear split between the control plane, so the software components, and the data plane, which we're largely running in hardware. So the control plane, the software components of OpenStack that we're using are there just to configure the hardware, and we can afford, although it's not desirable, we can afford to lose parts of them if necessary during a deployment. So what you'll see, we're actually going to deploy to production when I actually show the Helm update, and yeah, it won't affect any of our users because everything that they're actually running is running outside of the control plane. But a typical chart for us would then look something like this. There's essentially a deployment, which is deploys the pods. We've got an ingress controller if it's an API that needs to be accessible by the end users, and then we deploy configuration into config maps based on templates. So we have a bunch of templates in here which correspond to the OpenStack configuration, and we inject those via config maps, and then the values here are either coming from the chart itself or a chart hierarchy that we've built up to create a regional deployment. So there's a lot of variation between regions, but the the only real variation is the things like passwords, the IP addresses of host names and hardware, and things like that. So the actual charts themselves are a template for the region, and the only thing that we're varying is the quantity of hardware or the way we access it. So these charts here are basically the blueprint of our OpenStack regions, essentially. And we also then, within a typical OpenStack chart, have a requirement on a database. So we pull in Postgres here for most components. I think we're using MariaDB somewhere else, but it's largely Postgres. And what we do is we then compose all of these components, which are to some degree almost identical in terms of the way they're built up, with a deployment configuration, some custom scripts, and a service and an ingress controller, and we basically bundle those together into a chart which is composed of all of the dependencies we need to build out a single region. And this is essentially an abstract chart that you can't really deploy because it's got generic values or placeholders for values. But it's there to essentially define what our OpenStack release is. And then what we're doing is we're taking this abstract meta chart, if you like, and we then build a set of regions around that. Unfortunately, I can't show you one of our real regions because it's full of passwords and various other stuff that I'd get fired for showing you. But we've created an example one here, which takes as its requirement the abstract chart, and then defines a set of values to actually make that a concrete region. So it's got all of the passwords, it defines the actual region that we're deploying into, the source of the images, and it also defines the hardware that we're going to deploy in here. So we scale out horizontally with additional VMware vCenters, for example, and we can just create an array of those, and it'll build a deployment for each vCenter we have. We have the same for filers that we're using for NFS shares and for network components that we need to have in place for things like DHCP and load balancers. And we define all of these within the region, and there's slight tweaks to the individual components, so adding in passwords and various other stuff again. And that regional chart then is ready to deploy. And there's a small make process that essentially does a dependency update and package for all of the charts in the repository, plus the chart in the region, and then we end up with a regional. So here we end up with a regional set of charts here. So we've got one for EUD1, which is one of our European regions. We've got one for Sydney here. We've got one for our staging environment at the moment in here, and these are essentially the deployable entities. So if I just then do an update, I've made a change to one of the images that we're using in our Neutron components, and hopefully, if I now do an upgrade on that region, it'll hopefully redeploy all of our Neutron components and some of our compute components that are using Neutron to make an update. And we can do that for the entire the entire OpenStack control plane. So we can go from a bare metal region to a fully running OpenStack environment in maybe 20 minutes or something like that, which for us is pretty cool. And we're hoping, we're seeing a lot of value in Helm, I think, and there's a few things we can't do and a few little nice to haves that we'd like, but in general, it's already, I think, surpassing some of the tooling that we built ourselves to do the same sort of stuff. And hopefully now, if we go back, we're back to a fully running environment again. And that's, I guess, in terms of a very quick overview of what we're doing. If there's any questions, we're happy to answer. I'll try to.
Very cool. Do we have questions? I have a question. Where do you host your charts? The core ones that actually define what we're deploying are on in our organization on GitHub. It's SAP-CC OpenStack Helm. This guy here. I guess we can post that in the chat. We have then an internal private GitHub repository that we're using for essentially secrets, and that's something we're hoping to change so that we can actually. One of the big problems we've got is there's a lot of shared values between charts, and they're siblings. They're not dependent charts, and we need to be able to essentially have multiple inputs into a single
release, and hopefully there's some pull requests we've seen around multiple value files that will hopefully allow us to do a lot more with just a single repository. But right now we have this regional repository which we have to keep private, unfortunately. But the core of everything that we're doing in terms of the OpenStack stuff is in this OpenStack Helm repo.
Thank you. Yeah, it's so nice to see an example of a complex chart, because a lot of people are trying to do more complex things with Helm, and this is really great. So thank you so much for sharing. Does anybody else have questions? Okay, we'll save some time at the end.
Just maybe I have a question. I don't know if anyone has a view on it. I mean, one of the things we're constantly debating internally, and I think some of it's driven by the legacy way we used to deploy this stuff, is whether we're actually making it too complex. Because for us, at the moment, it's very easy just to do a single deployment of a region and everything comes up. We're wondering whether we can get some level of granularity so that we could just, for example, deploy one single component like the networking component in Neutron. And we're not, a lot of it's driven by legacy, but some of it is our perception, at least, of problems that would arise around particularly shared values, but also being able to share dependencies where things get deployed multiple times when we only want them deployed once, for example. And it'd be interesting to know if anyone else is doing a sort of a similar thing, but with granular control, because it's a constant discussion we're having, and it would be a lot easier for us to manage individual components. But right now, the only way we can see it working for a really complex application like OpenStack is a sort of big monolith. So I don't know if anyone has any feedback or can think of anything, but if there's any similar use cases, it'd be really interesting to get in touch with people.
The shared dependency conversation has come up several times. I think there's an issue on it. Does anybody else have that same concern here? I think there's an ongoing discussion on it. Let me pull up that thread and share it with the group. And then we can also come back to this. Okay. If there's silence, we can continue. Thank you again for sharing. And then there's some comments in the chat as well. Eric says, thanks for sharing. Great for tool developers to see, tool dev to see complex examples. And Jay Nowak has some questions for you offline. So he's asking for your Slack handle, and those are posted. Great, thank you. Okay, so let's go on to serverless on Kubernetes with Fission.
Hi, can you hear me?
Yes.
Okay, so let me just share my screen here. Right, so we've implemented a simple sort of functions as a service framework on Kubernetes, and we're going to do a couple of small demos about it. But before that, I wanted to set a bit of context. So first of all, why create something like this? We wanted to enable a few simple use cases. One is we saw that users want an easy way to create an API backend without necessarily understanding everything there is to know about building containers and creating a Kubernetes service, deployment, and so on. So in some sense, this is automated serverization. We want to be able to create a service from just an API endpoint. Just write a function and map it to some API and create a service from that. And there's a few other use cases, especially around event handlers. And in particular, Kubernetes events can let us do things like create custom Kubernetes controllers. If you, we'll demo this later, but we can map a function call to a Kubernetes watch and use that perhaps to create a custom controller. It's also a great use case for webhooks, and it's also good for new users who don't really know everything about containers and Kubernetes. So, so what does fission actually do? It lets you write a function in any language, where any today is Node.js and Python, and we're adding support for new languages rapidly. It lets you map these functions to triggers. So you can have an HTTP root, some sort of event, or a timer, and have that run the function when it occurs. The function is lazy loaded, so it's sort of free when it's not running. CPU and memory resources are only consumed when the function is actually triggered. But we also want to make sure that that it can start very quickly when it's needed, and we'll talk about how we do that. It's important to note that the user operates on just the code. Most of the time we abstract away the container image building. So the user can just provide a function with fission. And the case where they can't just abstract away containers is when you need to add dependencies or something else to the container image that the function depends on. In that case, we allow the user to add their own container images to fission. So I also wanted to quickly talk about why such a thing should be built on Kubernetes and not as a separate cluster. One thing we realized while sort of analyzing the functions as a service in serverless space is that it works best when it coexists and interoperates with other services. So we want to integrate well with other services on Kubernetes and with the Kubernetes features itself. So things like configmap, secrets, persistent volumes, and so on. We want to be able to have functions take advantage of those things. So a quick sort of overview of how it works. Since we want functions to be able to start quickly when they're requested, we keep a pool of running pods that are capable of running any function. And they do that by having a simple dynamic loader inside them and an HTTP server that can route requests to the function that's loaded. And then fission takes care of sending the function into that pod using a sidecar container and so on. And this little piece is the only language-specific code in fission. So it's 100 or so lines of Node.js and Python and so on to actually load the function for that particular language. When there's an HTTP request, a pod is picked from this pool. The function is copied into that. It's loaded, and the request is proxied. That takes about 100 milliseconds, usually. Hopefully the demo will comply with that time limit. And if the pod is cached for a while, if there are no requests, after a while it's killed. But subsequent requests within a few minutes don't need to take that overhead either because the pod is cached. And for other event sources, we route them over an internal HTTP route. So the function is always called over HTTP. Okay, so let's see two short demos. One is a simple hello world, and one is a demo of a Kubernetes watch. Can you still see my screen? Sorry. Yes. Can you see my terminal, or is it?
Oh, no.
Oh, sorry. I'm going to try to share my. Oh, okay. Does this work better?
Yes, we can see your terminal now.
Okay, thank you. All right. So fission runs as a service on top of Kubernetes, and it uses etcd and so on to store its own state. And I want to show you the state of the Kubernetes cluster before we run any functions, and then add a function, run it, and then see what happened on the cluster itself. Okay, so on our fission, so we have a fission CLI, and I spoke about the dynamic loaders and HTTP servers. Those container images fission calls environments. So you can list the environments that have been added to fission. So on this deployment, we've added Node and Python, and that causes a set of generic pods to be created. So we can look at those. And we see 3 of the Node.js pods and 3 Python pods. These pods are idle. They're just sort of waiting there to accept a function and send a request to it. And so let me just say there are 3 Node.js pods right now. And now let's create a simple Node.js function I want to show you the hello world function first. So since it's Node.js, everything happens by callback. So the function entry point is the entry point of the module. The function gets a context and a callback. The context contains HTTP parameters, form data, request body, and so on. And the callback is what you call when your request is finished. So in this case, we send a 200 OK, and we say hello world. So let's add that function to fission. And we tell fission to use the Node.js environment for that function. And it's simply created. At this point, the function is only stored in fission. The number of pods still remains the same. Then we map an HTTP route to this function. So a get method on /hello will call the function. All right, so you add a root, and we see a root is added here. And now we can call that function. I'm going to do it through GKE's console because I don't want my sort of noisy Wi-Fi latency since we're going to measure this. So the first request takes about 200 milliseconds. And the second one takes about 80 or so milliseconds. So the difference here is the overhead, which is 100 and something milliseconds. So that's the overhead that we took for copying the function over, loading it, and routing the requester. And subsequent requests take a shorter period of time. And now we can see the number of pods that got created. And so now there's 4 pods. One of those pods is the one with the function. There's 4 because when we choose a pool out of the pool, we replenish the pool back. And we also label pods with the name of the function. So you can find your pod and use existing Kubernetes tools to examine the logs of the function and so on. So you can see our get requests are logged here. If you have any other logs, they appear here. If you have log aggregation tools set up for your Kubernetes pods, then you can just continue using those tools with fission. All right, so that's the Hello World demo. I also want to show a simple demo for watching Kubernetes events. Are there any questions so far? Okay, so I'm going to switch to a different Kubernetes cluster for the Kubernetes events. So use the local cluster on my. Give me a second here. All right, so on this fission cluster, we have the Node.js environment. And we create a function that listens to Kubernetes events. And that's the Kubernetes event callback function. And I can just quickly show you what the contents of that are. It's a really simple function that is called with the serialized Kubernetes event. And what this function does is just sends a message to a Slack webhook saying, so-and-so object was added or deleted. This isn't a very useful thing by itself, but I just wanted to show the fact that we can react to Kubernetes events. And finally, we create a watch on Kubernetes, and this is implemented simply as a service that's listening to the API and creates a watch. So let me just delete that one. And so here we listen to all pods in the default namespace and have them call the Kubernetes event callback. We could also refine things by labels and field selectors and so on. So here we're watching all objects of type pod on namespace. And so let's create a pod to trigger that function. So let's just say something like, so we just created a pod in the default namespace. It's probably gonna error out, but we'll get to see hopefully what events got launched from that. And actually can't see my Slack, but oops. Anyway, so you can see right now that a message was sent to the Slack. We pulled out the name from the object metadata and the object type. Again, like I said, sending such kind of messages to Slack is not super useful, but we want to be able to use this framework to do more interesting things with the watch, such as maybe writing stuff. So that's it for the two demos. If there are any questions, I'd like to answer them now. I can talk a little bit about the roadmap and what we're doing next.
I think you have some questions in the chat.
Oh, okay.
Eric asked if pods are recycled.
Oh yeah, good question. We do not recycle pods today, but we could. Pods are recycled for the same function for a few minutes, but after that function is idle, we kill the pod, because in the most general case, we don't really trust the function to have left the pod in a state where the next function can use it. Now there's definitely maybe 90% of the cases where actually you can trust the function to leave the pod in a good state. So we'll probably allow some sort of annotation or something on the function where a group of functions could say trust each other or something like that, and we could allow pods to be recycled. Does that answer the question? Can one pod name run two or more different functions over its lifetime? Yeah. So pods today run only one function. Again, it's relatively easy to change that, and we're looking at it. Again, it's a matter of do functions leave the pod in a good state? Is there global things that they're modifying, and so on. Question about npm dependencies. Yeah. So today, the way you change dependencies is by rebuilding the container. There's a package.json in the container itself, and if you want to change it, you just edit that and rebuild the container and do a fission env update and point at your new image, and we'll use that image for other functions. We're investigating attaching a package.json to functions itself and doing smart things like copying directories around, but it seems simpler to just rely on Docker for packaging right now. Okay, did I answer the question? Yeah, okay. So if I still have some time, I'll quickly go over a few things that we're doing in the roadmap. So we want to add more languages. Right now we have Node and Python. We're adding Golang support soon. We want to add more Kubernetes integration, allow functions to request access to configmap secrets and maybe even persistent volumes. We're talking to other folks to add event integrations. So if there's any event that you think would be useful to trigger functions on, please come talk to us. We're also working on improving the UX. We saw a few people using this so far and realized that the tooling around testing and so on needs to improve. So we're working on that. And finally, today we don't autoscale a pod, so we need to do that today. There's only one pod behind every function, and we can transparently add that so that functions can be more scalable automatically. Serverless in general has a problem that any complex app is going to have a big sprawl of functions. So we'll be working on tooling to perhaps group functions together or add some sort of composability, maybe some sort of module system. This is sort of a little further down the road. And we're also talking about version control and things like that. So thanks a lot for listening. Here's our website, our Twitter, and our GitHub. I'm also on the SIG-Apps and on the Kubernetes Slack as well. And here's a GitHub repo. So any questions, feel free to send them my way. Thanks a lot.
Thank you. All right, let's go into stand-ups. Adam Reese, do you want to do a stand-up for Helm?
Yeah, sure. Happy Monday, everybody. Quick update. This week, we're looking at doing a 2.1 release. Couple of features in there around when you delete a chart, persisting specific resources, have an annotation for that. As well, the other big feature is going to be 1.5 support. And that's about it.
Thanks, Adam. Okay, and app controller team, y'all have an update?
Yeah, hello. So, hello again, from app controller team and Unity. So, basically, this week we focus on some refactoring. We have almost done Helm integration, POC quality. We are expecting that it will land pretty soon. And Piotr Szewczak from Unity is in Sunny did a presentation about app controller on Bay Area Kubernetes meetup. And that's basically all from our side this week. Thank you very much.
Thank you for your stand-ups. If there are no other stand-ups, we'll go into discussing a proposal for adding a way for projecting secrets, config maps, and downward API into the same volume. Paul and Jeff, are you around for that?
Yeah.
Take it away.
Hey, everybody. I'm Paul. I know a bunch of you on this call, but I work on Kubernetes at Red Hat. So one limitation with the volumes for the different system integrations with secrets, config map, downward API is that there is not a good way to put those things into the same directory right now. Jeff, who is going to start talking in a second, if he can figure out how to unmute his audio, recently joined our team here at Red Hat working on Kubernetes, and one of his first tasks has been to make a proposal and do a prototype of a feature that lets you put all these things into the same spot. Jeff, have you figured out how to unmute your audio yet? I'm hearing a no. I think this is Jeff's first time using Zoom. Jeff, mouse over the Zoom window, and it's in the lower left-hand corner to let you unmute.
I unmuted him.
Okay, it seems that I've been unmuted. Thank you for that.
Take it away, Jeff.
So now we'll try and share my screen. Okay, can everybody see that?
Yes, thank you.
Assuming so. Okay. So what I'm going to show you today is essentially work in progress for the implementation for the system volume driver. So I'll just start from the very beginning here. These are two files that are creating the config map and secrets. There's nothing special about them. It's just I needed a couple of them to demonstrate. So once we start a pod, which I will show you what that pod looks like here, is you can see here, specifically this line right here, the system line is what enables multiple sources to be able to be utilized, to be able to be mapped back to the all-in-one mount point here. And just to be able to demonstrate what it looks like the current defined way with separate mount points for each resource. I have here a secret that is mapped to one secret here. So if we go and look into the pod, we can see that inside the one directory, that's the normal secret. That's the way it's been always working. But here in the all directory, we have projected the secrets and the config maps all in one directory. So that's the main part of it. So the second part is handling collisions, and to be able to demonstrate that, I will show you the pod spec right here. It's just simply defining, sorry, that's the wrong file. It's defining two downward API with the same exact path. So that's not going to be allowed. So when I try and attempt to create it, it shows a couple error messages indicating why that was true. So that's pretty much it in a nutshell.
So Jeff has a proposal for this that is currently made to the main Kubernetes repo that he's going to move over to community. And we are interested in feedback that folks might have on the API and how usable it is. And I'll just say one more word, that in the future, we hope to allow you to project this volume on top of another piece of the file system in a container without overriding what is already there. So if you have like a software package that has a configuration directory of some kind, you want to put one or two files in it, but you want to keep the rest, eventually we want to be able to do that. So thank you, Jeff. Thanks, everybody.
Thank you, Paul and Jeff. Does anybody have any questions at this time? Eric, I think you're talking, but we can't hear you. Are you talking to us? Yeah, we can't hear you. So the link to
Can you hear me now?
Yeah, and the link for everybody is in the meeting minutes. All right. The last item on the agenda is the planning for 2017, and I'll hand it over to Eric to lead us to kick that off. And if we need more time next week, we'll continue. And I suspect we will need more time next week.
Can you hear me now?
Yes, we can.
Awesome. So I shared a Google Doc. Does it make sense to project that, or just have everybody look at it if they want to?
I think you should project it.
I will share the link and attempt to project. If there's a quick thing you want to do beforehand, I'm going to take me a second to get it all up.
Yeah, sure. I can just make a few announcements. Kubernetes 1.5 release should happen later today. There's a link in the agenda for the SIG-Apps related 1.5 features, if you're interested in checking those out. And last week's community meeting had a segment on the Kubernetes 2017 roadmap. And so I also linked the slides from that in the doc. And we're planning on having one release per quarter, if anybody's wondering what the release cadence is going to be like.